Okay, so today let us start off with this program where we have to create a change pally number class. And in this change pally number class, we have to take a sentence as input from the user. And we have to find out all the integer numbers from that sentence. And first we need to check whether those integer numbers are palindromes. And if those integer numbers are palindromes, then we have to encrypt those integer numbers. And the process of encryption is as stated over here. 1 will get converted to small a, 2 to small b, 3 to small c, so on and so forth. So you see there is an example given over here. 14641 is an integer number over here, which is a palindrome, so it has been encrypted. 11545 is another integer number, but it is not a palindrome, so it has not been encrypted. 442244 is a palindrome number, so it has also got encrypted. Now, as you go through the program, you do understand that this program has certain things similar to the program that we did last day. So, some of the portions of last day's program we are going to take from there. Now, over here, obviously we have to create a class change pally numbers, and this is the string data member that has been taken inside the class. This is the constructor, a parameterized constructor, and s has been given the value of x. This portion we did last day. We also had taken parameterized constructor yesterday or last day's class. Now, in the last day's class, we also had this function called find numbers. Now, this find number function, what was the purpose of this function in the last program? The purpose was to split the string into words and create an array of words and then process each of the words separately. So if you remember, we had used this split function over here. This, when you apply s.split, then the sentence gets split into words, and since we are assigning those splitted words into an array, so the splitted words goes to an array. So if we take the example given over here, there were 14641 boxes. When you split, you see the delimiter given over here is a space, correct? So as a result, the words are splitted through the delimiters. There were 14641. All these individual words are split because they are delimited using a space, and they are put into the array that is there in this ARR array. Okay, we have taken a string over here, SR. The purpose of this string is, as you can see over in this output, we have to create the sentence again. Now, one of the very important characteristics of string as a data type is that when you have a variable of string type, the string type variables are immutable. You can assign values to the string type of variable, but you cannot modify them. You just cannot modify them from middle. You can add a string to the current string, but you cannot modify the string from in between. So strings are immutable in nature, and that is the reason when we are creating the modified sentence, we have to create in a new string. Again, strings are immutable in nature, so as a result, whenever you are creating a modified string, you have to create it in a fresh variable. You just cannot go and modify the existing string. You can assign values to a string, but you cannot modify them. Now, we don't need this variable. Now, over here we have created a loop where we are starting from the beginning of the array and we are going till the end of the array. And this is what we did in the last class. We were searching whether each of the elements of the array were number. We had created an isNumber function. IsNumber function was a UDF which were checking whether this particular string passed to it was a number or not. So the same function I have taken over here with bit of changes. You see isNumber string x. Now over here the number has to be integer only. The number has to be integer only. So as a result, again over here I have used wrapper class to uh, check whether the number is integer or not. So what I am trying to do over here is I am trying to convert x to long type. Now as I discussed last day, x will only get converted to long type if and only if it is a number and it is integer in nature. Otherwise it would give a number format exception. So over here we are trying to convert the string to an integer. If it gets converted to integer, then we are returning true. That means this is a valid number. If it does not get converted to integer, then uh, it will throw an exception. It will come to the catch block from where we are returning a false to show that the the string passed is not a number, or even if it is a number, it is not an integer. Now we will come back to this if condition. So isNumber ARRI tells us whether ARRI element is a number. But in this program, the number has to be integer plus it has to be also a palindrome. So we have to create a new function called isPalindrome to check whether the number is a palindrome or not. So we will check whether isNumber is a palindrome and isNumber function will check whether the element is a number, and isPalindrome function will check whether the given string is palindrome or not. Okay, so let us write this isPalindrome function. The return type of the isPalindrome function will also be Boolean in nature because it will return true or false, and it will take string x as its parameter. Now inside the parameter it will check whether the given string is palindrome or not. Now what logic should we apply? Now first let me tell you what is the logic of the palindrome function that I am using over here. Let us assume that this is the number we are checking for being palindrome. Now this number, mind you, is in string format, right? Because we have taken a sentence and this number is also part of that sentence, so this number is also a string. Now this number has been put into an array as an array element. Now we know that a string is a character array and it starts from the position index 0 and it goes till length -1. That means the length of this particular number is 5. So 1 is at position 0 and the last one is at position 4, that is length of the number -1. So in this function I am going to run a for loop which is going to check the 0th position with the length -1th position, First position with length minus 2 position, third position with length minus 2 position, so on so forth. So you see, if I work with a loop variable I, and if this is the ith position 0, then this is ith position length minus 1 minus 0. If this is the ith position 1, then this is length minus 1 minus 1. This 3 is at length minus 1 minus 1. If we are over here, that is I value is 2, then you are going to compare that with itself, that is at the position length minus 1 minus 2. So therefore you are going to check every position character with length minus 1 minus I. This was length minus 1 minus 0. This was length minus 1 minus 1, and this is length minus 1 minus 2. So for every ith position of the string, you are checking it with length minus 1 minus ith position of the string. So let us go back to the function. So we are going to run a loop for int I is equals to 0, I is less than x dot length I plus plus, and then if not x dot char at I double equals to x dot char at x dot length minus 1 minus I. So if these two characters are same, then it is fine. If they are not same, then that means there is a problem, and that means the string is not a palindrome. So straight away you return a false. Straight away you return a false. But if the loop manages to run till the end, that means your string is a palindrome and you are going to return a true value. Now, before I move on, you see when we are checking, again let's get back to the working that I was showing you. If we see, it is enough if we check till half of the string. We need not check for the whole of the string. If we check for the half of the string, then it is enough to prove whether the string is palindrome or not. So that is why over here we will take the length from 0 to length divided by 2. So this is a function which will tell you whether the given string is a palindrome or not. So this is returning you back true or false, and you come back to this if condition. Now if this number is a number, if this string is a number and it is a palindrome, then we are going to encrypt the string. We are going to encrypt that particular number. We are going to encrypt that particular number using the rule given to us. So now let us frame the encrypt function. Now this is the encrypt function over here. Now, the encrypt function, obviously, the return type of the encrypt function should be string type, because the encrypt function is returning you the value which you are putting back into the array element. So, the return type of the encrypt function is string. Now, over here, what we are doing is we are taking a loop which is again going through the length of the string of length of the element of the array. For example, if the array is again, let's come back over here, if the array is 1 2 4 2 1, then we are starting from 0 and we are going till the length of this whole number, right? Now let us see what is the process of encryption. Come to this sentence. Now this is the sentence where you learn how to convert a number to a character to its ASCII and how to convert a number to the character form. Let's look over here. X dot char at I. I starts from 0. So let's come back over here. Now when I starts from 0, so char at 0 gives you 1, char at 0 gives you 1 according to this number. So x dot char at I gives you the number 1. Now this is in string form. This number is in string form. So when you say x dot char at I, which gives you 1, and when you write integer, you see this is explicit type conversion of the character to its integer. So when you are explicitly converting the character to its integer, you are getting the value 49, because 49 is ASCII of 1, correct? So x dot char at I gives you 1 because I value is 0, and when you're converting this character to its integer format, you don't get 1, you get the ASCII value. So the ASCII value is giving you 49. Now over here, if I want to convert this into a small case A, ASCII value of for 1 is 49 and ASCII value of small a is 91. So 91 minus 49, that is the value that I have to add. ASCII value of small a, ASCII of small a is 91, and ASCII of 1 is 49. So therefore, to convert 1 to A, I have to add 42. To convert 1 to A, I have to add 42 to the value. If I add 42 to the value, I will get A out of 1. Now just to explore the function to lowercase, that is why I did not add 42, I added 16. Now when you add 16 to 49, when you add 16 to 49, when you add 16 to 49, you get the number 65. That is ASCII of capital A. See, you could have added 42 right away, but just to explore this next function, I have used 16 instead of using 42. But obviously, you can use 42 and do away with the next statement altogether. So, char at 0 is giving you 1, that is, and when you are converting it to integer, it is giving you the value 49. I am adding 16 to it, that is giving me the number 65, which is ASCII of capital A. Now this whole number this whole number 49 plus 16, that is 65, has been again converted to char. So you see, this is the process of getting the ASCII, and this is the process to convert an ASCII to its corresponding character, right? So by typecasting an ASCII to char, you convert the ASCII to its corresponding character, and by converting explicitly a character to int, you get the ASCII value of that character, right? Now, in the next line, what I have done character dot to lowercase c. So this c I have got in as capital A, but according to the question I need to print small a as encrypted value. So that's why I have converted it to lowercase. Again, I am telling you, it is just to explore this function. That's why I have done this process. You could have easily added 42 over here and straight away got a small a, right? Now you go back to the loop. I value becomes 1. Now when I value becomes 1, I goes to the next character. When I value becomes 1, it goes to the next character, that is 2 over here. Now again, when you do x dot char at I, you get 2, and when you convert it to integer, you get ASCII of 2. What is ASCII of 2? 50. And I am adding 16 to it. So 15 plus 16. So over here, I am getting ASCII of 2 for the next character, which is 50. And I'm adding 16 to it, so I'm getting 66, which is ASCII of capital B. So you see, 2 is getting converted to capital B, and again by passing it through the function to lowercase, I am converting it to small b, right? So that is how the encryption process is taking place. Now, so after it gets encrypted, the encrypted string gets passed to the function over here, and as the encrypted string gets passed over here, we are concatenating it with the new string that we have taken. Now, if the given element of the array is not a number, or it is a number but it is not a palindrome, then the if condition will not work, and straight away the string or the number which is not a palindrome will get concatenated with the new string that we are creating, right? Only if the number is an integer and it is a palindrome, then only encryption will be called, and then the concatenation will take place. Otherwise, whether the if condition works or not, the concatenation will as it is take place inside the for loop. So this SR gives you the total modified string. Now we come to the main function. The main function, obviously over here we have taken a scanner class because we have to take the input from the user. As we have discussed last day, the way to take a string input is using next line, and then we are calling the change pally. We are creating a change pally object, and then we are calling the function find numbers. This is returning back a string which we are printing in the console, right? So now let's run the program and see whether the program is running or not. So we come to the command prompt, change value numbers.java. Okay, that compiles perfectly, and then we run the program. It is asking for a string. Let's create our own string. There are, let us say, 787 boxes, and boxes and 554 apples and 6, 7, 8, 7, 6. Oh, sorry, that's not a palindrome. 6 oranges. Okay, let's see. So you see, this is a palindrome which gets converted. This is not a palindrome, so this does not get converted. And this is again a palindrome, so it gets converted. So therefore, this program works perfectly. Now, you see there is a space that is coming over here. What is the reason for this space? The reason for this space is when I concatenated the strings, the new string that I created was empty at the beginning. Now, whenever I'm inserting a word, new word, I am inserting a space, right? So I am inserting a space first, then I am inserting that word. So even the first word that gets inserted is preceded by a space. So what we can do is we can use the trim function to trim off that extra space that is there. So where do you basically apply the trim? After the whole string has been created, before you return the string, you just write sr is equals to sr dot trim. Now what does the trim function do? Trim function trims off all the spaces before and after a string, preceding and succeeding a string. Now in between spaces are not truncated or trimmed in this trim function. So only the preceding and the succeeding trim blank spaces are trimmed. So now let's save it and see whether it works or not. So again we compile and so there are, let's give some other number, 323 boxes and 667 apples and 8998 oranges. So you see the preceding space is removed. Clear? Now that so what did we learn from this program? Basically, this program basically taught us how to convert character to its ASCII and vice versa. Plus again in this program we have used try catch, we have used wrapper class, and we have also used how to convert this number to a character, that is encryption process, how you can add ASCII number to the ASCII value and change the character altogether and recreate the whole of the string on you. Okay, so I hope you have understood, and we will do a lot more such programs in the coming practical sessions. Now a small modification to the video. ASCII of small a is not 91, it is actually 97. So as I told you that you can go and convert your number 1 to ASCII to small a by directly adding the value 48 to the ASCII of 1. So ASCII of a is 97. So to directly get small a from the number 1, you add 48 to the ASCII of 1, not 42 that I mentioned earlier. So you have to add 48, so you will get 97, and that will be ASCII of small a. Correct? So I have done the program with capital A, but ASCII of small a is 97. So if you directly want to convert 1 to small a without using two lowercase function, then please add 48 with the ASCII of 1.